Hi and welcome back. This is our last episode of the ASP.NET Core Authentication Basics system, and what we're going to do this time is basically start directly where we finished in the last episode, where we added an additional authentication method to our login page. So if you remember, we had a login page that allowed us to log in with a local username and password, and with Google, and we added all kinds of other things like the callback pattern to post-process the data coming back from Google and so on. So what we're going to do in this episode is basically get rid of all of this and switch to a very common pattern where basically you outsource all of your authentication to a trusted authentication provider, which in our case would be OpenID Connect and Identity Server. So we're going to start by deleting things from our application. So let's do this. We will not need anymore a login page, right? The complete login process will be outsourced to this external authentication provider. We don't need our callback logic anymore, so we can delete this as well. We will have a logout endpoint. We're going to have an access denied one. That's fine. And in our program CS, we can simplify things as well. We don't need the temporary cookie anymore. We don't need our Google authentication anymore. So that's what we have. We're going to leave our authorization policy in there. So the OpenID Connect provider we're going to now wire up is basically our demo server, and you can use this as well if you want to. It's at demo.duendesoftware.com, and basically it is a server that is set up with a couple of demo clients for, like, machine-to-machine communication and other CRAN types and OpenID Connect flows. And the simplest one we want to use is basically just a client called login, which just gives you back an identity token, and you can then play around with the claims coming back. Okay, so that's what we're going to do first. So to enable this, we need a new package here, so we can remove the Google authentication package and replace this with the OpenID Connect authentication handler, and then we can wire up our OpenID Connect handler. We're going to give that a name as usual and some configuration options. And the way the authentication handler from Microsoft is set up by default is pretty simple. All you need to do is point the handler to the location where your trusted authentication provider lives, which in our case is this URL here. And then if you're interested under the covers, what then the authentication handler is doing is basically using this URL to construct the so-called discovery document URL, which is basically a relative path underneath that base URL, which has this well-known name. And from there, it can pull all the configuration information, including the physical URLs, where to send the user to, and also the key material that can be used then to validate the identity tokens coming back. Cool. So that's all we need. And then in this very simple case where all you do is do a login via OpenID Connect, the default settings of the OpenID Connect provider are already set to using what they call the OpenID Connect implicit flow and returning the so-called identity token. And so all we have to provide really is the name or the ID of the client that we want to use for the authentication flow. Cool. So that's good. Now the next thing we need to do is we have to now basically to make this system work, we now have as usual, we have one authentication handler that implements the protocol you want to use, and we have another authentication handler which implements the session management. Now to make them work together, they have to share the work now, right? So for all of the things like signing in the user, you want to use a cookie. and also for signing out to end the session, you want to use the cookie as well. But for example, for challenging the user for authentication, you want to use OpenID Connect. So to make this work, we're going to have to change this a little bit and pass in some options here. And we're going to say, okay, so by default, we want to use the cookie handler for everything, but there's one exception here, which is our challenge scheme, which I want to set to OpenID Connect. Actually, you could also set a sign-out scheme here. There are different ways of doing that, but for now, this will be fine. So, in other words, what should happen now if I run this is when I'm hitting my secured endpoint, and remember that has an attached authorization policy, it should invoke whatever is configured to be the default challenge authentication handler, and that should bring us to our login page of our demo server. Before I log in here, I want to show you another change that I made in preparation of that video, is that our secure page is a little beefed up. And something I haven't talked about in earlier videos is the concept of an authentication session, or at least more in depth about the concept of an authentication session in ASP.NET Core. So far, the session for us was basically the claims of the user, right? And that is accessible via a shortcut, basically for the using the .user property on the controller, on the page, and so on, right? But ultimately, where this data is coming from is from this underlying concept of an authentication session. And the way you get to the authentication session is by calling authenticate async on the default authentication scheme, which is our cookie, right? And what you're getting out of there is, data. And one of the data you're getting out of there is the claims of the current user. But another piece of data you're getting out is, they're calling it the properties of the session. I like to think of it as metadata of the session, and you can store or retrieve additional data about the currently logged on user or things that belong to the user, like tokens and so on, and I'll show you that in more detail while we go along. So basically all I'm doing here is basically I'm reaching into the session, which then contains the claims of the user and these properties, and then I'm just making them available as a session object here so I can render this more nicely on that page. Okay, so yeah, let's do this. And get rid of this one here. Cool. So, okay. So let's run this. And log in with Bob and Bob. Oh, okay. 1 second. Let's run this again. So, Bob, Bob. Cool. So now, what we're seeing here is are basically two parts on our secure page. One, the above one is the user claims, and then the lower one here is the metadata. And you see in the metadata there are things like, well, OpenID Connect specific ones. We won't go into detail for all of this, but there's some session state which is later used for certain logout operations. There's still things like when was the cookie issued and when will the cookie expire. So that's basically your local session time. But yeah, shifting our attention first to the upper part, which is the user claims. Okay, so we talked about this in the context of the Google authentication provider, that Microsoft, in my opinion, made the mistake of trying to shield some details from you. So as you can see, the claims here, like these long claims, are not the claim types that are actually emitted by Identity Server. Identity Server is a standards compliant OpenID Connect implementation. We use the standard claim types for that. But Microsoft takes those claim types and transforms them, and long story, trying to harmonize them with claims from Azure AD and so on, which then gives you the impression that you're ending up with these claims here, which is wrong. Now, for many versions of ASP.NET Core, you now had to write some logic or reach down to some lower level parts to turn off this behavior and so on. But the first useful configuration option I want to show you on the OpenID Connect handler is the one that you should always use when you are setting up this thing. Is you say map inbound claims is false. Okay, so what this does is it turns off that mapping logic, which I think is wrong anyways, and you will get the raw, unmapped claims from your authentication system. So let's try this again. And now you see that we are getting the real OpenID Connect claims, AMR, SID, SUB, off time, and so on, which are, shorter on one hand, but also the real ones. And now you can, start transforming them, or, just take them as it is, because chances are that if these claims are coming from your trusted, authentication system, they are exactly already in the format that you need. Now, one common question I'm getting is like, would you use the same authentication callback pattern here as well when using OpenID Connect? And the answer is, well, you could, right? The callback pattern that we talked about in the earlier video is all about being able to inject logic after the external authentication system comes back to you, but before you log in the user or start the session for the user in your local application. Now, if you need to do that, you can use exactly the same pattern as I've shown you with Google in the previous video. But again, chances are that if you are using your trusted authentication system, that this might not be necessary, because maybe these custom steps have already been performed at your authentication system. But, could be a multi-step process, right? Short answer is you can use the callback pattern, but it's less likely that you need to, because you are talking to your authentication system and not Google, which by definition doesn't belong to you. Yeah. Okay, cool. So now we have claims here, and which claims exactly you're getting depends on the scopes you are asking for, right? So the OpenID Connect handler has some default values which are a bit unfortunate. So there's this scope collection here, which determines which scopes are being requested from the handler. By default, what the handler request is the OpenID scope, which is mandatory in OpenID Connect. So that is a fine default value, but it will also ask for a thing called profile. So this is unfortunate that this is a default value, because it's not mandatory. Some providers might not implement it, and that might result to problems here. So let me just show you what you would get with the minimum settings here. So when we log in to the secure system, to the authentication system, basically you see when you only ask for the minimum scopes, then basically the only user-centric scope you're getting back is the subject ID. Yeah, so there are many situations where that's all you need. You need some unique handle for that user, so that you can, hang off additional data. Yeah. The other claims you're seeing are basically protocol claims, right? So like, how did the user authenticate at the server that is using a password? What's the session ID, which is later used for logging out? When did the user authenticate to the server? So in other words, when did the session start at the authentication system? And the IDP claim is basically, telling the application if this was a local account or some external account like Google and so on. Again, there are more protocol claims. Microsoft filters some of these claims by default, and again, that's a common source of confusion. You are expecting certain claims to be present, but they are not. There's another property here called claim actions, and that basically is think of it as a collection of functions that Microsoft populates with some default values that you can modify, and that determines which claims from the incoming token are actually copied forward to the session. And I think you can clear this all together, which means the claims action transformation system is not being used at all. So let's try this again to unpeel some of these layers here. So let's do this. And now basically what you're seeing here is pretty much the unfiltered contents of the identity token or the assertion, however you want to call it, that came back from the token server. So you see claims here which are probably not useful to you. For example, the name of the issuer, or when does the token become valid, when does the token stop to become valid, or the audience, the nonce, right? I mean, and that's the reason Microsoft filters them by default, or applies some default filtering at least, because these claims here are typically not needed anymore. Like the nonce, for example, is purely a claim that is relevant during the protocol flow, and there's no need to put them into the session, which then increases the size of your cookie. So for most parts, this filtering makes sense. If for troubleshooting purposes, you are missing some claim that you expect to be there, then this is very useful to just turn off that mapping system altogether and have a good look what's actually coming in, and then reapply maybe some additional rules here. And I would encourage you to read the documentation of Microsoft how this actually works. There are a couple of ways how you can map from the JSON inside the token back to .NET types, so to speak. Okay, good. So let's add the profile scope back in, and then you will see that just like before, we now get additional claims about that user. Right, so now we will get things like the given name of the user and the family name and so on, right? And if we look at the documentation of this demo server, you can see when you scroll down that there's another scope that is supported by this demo server called email, and that is used basically whenever you want to get the email address of the user. So the OpenID Connect spec distinguishes between profile claims, which are typically like display things, like as I said, first name, last name, things like that, and email, which might be, like sensitive data or something that you don't want to expose to every client application. So by default, they recommend separating email and also the postal address, for example, from profile claims. So, but since this server supports that and it is allowed for this client ID, we can, try and see what happens if we ask for the email claim. And oops, like this, and run it again. Cool, secure, log in with Bob. And now what we should see is two additional claims here. One is called email and one is called email verified. Okay, so that's basically the interplay between the scopes and those claim actions. Yeah. Cool. So another thing we haven't talked about yet is logout. Okay. So let's go back to our code and have a look at our existing logout endpoint. And basically what we are seeing here is that we called the sign out async method, and that, as we know, is in our old version of the code, did clear the local session, and then we went back to our URL or our homepage, right? So if we would invoke the same thing now with our client here, so if we click log out, right, the local session would be cleared, So we are back to this page. If we would hit secure again, we would challenge the user to the authentication system. The user is still logged on at the authentication system, so we would get single sign-on, right? And we would immediately be coming back here. So this is not really logout in this situation anymore. We have to tell the application to signal your logout intent to the authentication system. The way we do that is basically by basically what we can do here is there's a logout return. It's called sign out. Return sign out action result, and then we have to pass in the name of the authentication scheme that should trigger the sign out. And if we pass in the name of the OpenID Connect authentication handler, this will know, okay, I have to go to this handler OIDC to that authentication system and trigger the sign out there. You see that it's a params collection, so you can pass in multiple authentication schemes. So for example, what you can also do is you can say, you know what, delete the local cookie and afterwards go to the authentication system. Now, a fully working single logout would ultimately delete your local cookie as well, but if you know don't want to rely on that, you can say, okay, log out the user locally and afterwards trigger the federated logout chain upstream, which is my recommendation. So if we do that and click the secure link, so we go to the authentication system, we log in. Now if I press logout now with our changes here, you see we are now back at our authentication server, and this is okay, do you want to log out? And yes, and so on. Okay, so now we are logged out both in the local application and at the authentication system. Now, don't want to go into protocol details here, but to do a real logout, you need at logout time send the identity token back that you got in the first place, so that the server can do some validation on that and can also allow you to jump back to where you came from. You know, a couple of things here. So for that to work, you need to preserve actually the identity token you got at login time. Now, that's a built-in feature of the OpenID Connect handler, and that is using this concept of the session metadata. And what you can do here is you can say save tokens equals true, and what that means is that the OpenID Connect authentication handler will collect all the artifacts that get produced at login time, for example the identity token, but also the access token, as we'll see later, and then store that in the metadata of the session. Okay, that is very, very convenient, but also, of course, has the side effect that your session cookie, if you're using the cookie to store that, will get bigger. Okay, so let's just see what changes by just putting that property in our system. So this looks unchanged, but if we scroll down now, you see here, if we look at the metadata section, you see that there's a new item here called ID token. And this here, also very useful for troubleshooting, is the original ID token that you got back at login time from your authentication system. And if you want to have a look at that, I recommend to use this jwt.ms page, and then you can paste in your ID token, and then you get a decoded view of that token, and here basically you see the raw data, right? Also very useful if you think like, hey, something should be in the ID token, but it doesn't show up in my session. Is some mapping wrong? That's useful to say, okay, that is the actual token that came back from the authentication system. Okay, but as I said, the consequence of that will be that your cookie, you know, now is already almost 3 kilobytes. Yeah, so that is, you know, the trade-off here, convenience versus cookie size. Keep in mind, you can fix this problem in two ways. A, you could store the ID token manually. There are events on the authentication handler. Or B, you could use a server-side session, you know, to store the actual session contents server-side and only emit like a, you know, like a session identifier instead. Yeah, so beyond the scope of this video, but it is a problem you can fix. Okay. Oh, sorry. I didn't. The last thing I want to show you is now that we have the ID token in the session, the ID token can be sent back by the authentication handler at logout time, and then we are getting a nicer logout experience. Basically, we're not getting prompted like, "Are you really sure you want to log out?" And also the URL back to the client application is now made available to the authentication system. And it can automatically redirect you back, or expose a link or whatever. In this implementation, we're just saying, okay, click here now to get back to to where you came from, basically. Okay, so that's very basic login logout with OpenID Connect. One thing I want to make you aware of is there are events on the handler, and there are a bunch of them, and you can pretty fine-grained, modify a lot of the behavior of the handler. I want to make you aware of a couple of them. One is called on redirect to identity provider. Okay, so that is one that is sometimes used, and that is if you want to dynamically inject parameters for that you want to send to the upstream authentication system. Yeah, like one example could be, for example, maybe the language, right? So maybe that here in the local application your language is German, right? And then you wanna and OpenID Connect has a parameter. The locale parameter that you can indicate to the authentication system you want to display the login page in a certain language, German in this case. So you could use this event, for example, to dynamically grab the current language and inject this as an additional parameter. Or maybe you want to give a hint to the upstream system which external authentication provider to use, whatever, right? If you have to modify the authorized request URL going upstream, that's the event that you can use for that. And very similar to that, there's one called for sign out, and that is exactly the same idea, just for modifying the URL to the end session endpoint to the upstream system. As I said, there are lots of other events which are useful if you want to do more like low-level modifications of that system. For example, what could be another one that is on token validated? Yeah, if you want to have code running after the token has been validated, for example. Yeah, and so on. Okay, so that's that. So now what we have now basically is a client application which completely outsourced the authentication flow to an external authentication system, which is basically what we wanted to achieve. Now, as a last thing that I want to mention is what if you are using a more advanced flow, maybe you're asking for access tokens to call APIs and so on. How does that work? It is very nicely wrapped up as well in the OpenID Connect handler. So if we go to our demo server, you can see that there are additional clients which also have access to APIs. Okay, so basically what our application is, it's a web application, which is an interactive application, and it's server-side, yeah, which makes it a confidential client. That's how this name came together. So there's a client called interactive.confidential that you can use instead of our login client. So let's change the client ID here. Okay, now since this one will also give you back access tokens to call your APIs, this is, as I said, a confidential client with a client secret. So let's also set up the client secret here. Okay, now what else can we do? This mentions this thing called Pixie, which is an additional security feature that you always have to enable if you're using the authorization code flow. So what we're going to do first is we're going to say, okay, our response type is now code, where we're using the authorization code flow, and our response mode is we're going to use, we're going to transmit that code over the query string parameter. And then you see here, it has this thing called use PXE, which is turned on by default, so you don't have to set that. So this sets us up for an authorization code flow with PXE, using the query response type, using a confidential client with client ID and secret. And now we can also ask for access to an API, which then ultimately will result in an access token. And also what we can do is we can ask for this special protocol scope called offline access, which will also give you a refresh token, which then afterwards allows you to refresh the access token to have, like a long living access to the API. Cool. So these are the changes we had to do. And let's run this again and see what changes. So we're going to go to secure. Okay. From an end user point of view, nothing has changed, right? We have logged in. And before we look at the claims, I want to point you to the metadata. So you see now we have the ID token, which is here, but now we also have an access token, which is now the OAuth access token that now when you're calling an API, you can put on the authorization header and call that API. So actually, let's have a look at that access token, how that looks like. Okay, so what you see here basically, yes, it is an access token. It's AT plus JWT as the token type. We have our API scope in there, so you can call whatever API is called API. Yeah. Here's our client ID, the user ID, and all the typical things that are in an access token. So now you could now in your application, basically, let's go to a random page. You see here, you could say HTTP context dot get token async, which then will reach back into the current session. And then you say, give me this thing called access token, right? Var token equals, await this, right? And then call your API. So that's how that would work, okay? And if you would like to do, that access token will expire at some point. So if you would like to get the refresh token to get a new access token, you would do this, get the refresh token, and so on. Or there is a project on GitHub that I should make you aware of, which automates all of that access token, refresh token, management under the covers, which is called Duende access token management. So if you are in a situation that you want to call APIs from your web application and you need to do the refresh token management, then this is a very useful library to look at. I won't go into details here, but I encourage you to go to here and go to the wiki, which has the documentation for that. Well, GitHub is very slow right now, but yeah, here it is. Okay, so here you have documentation how to use this in web applications and worker applications and so on. Cool. So yes, and here's the refresh token. In case you haven't seen it, it's here. Okay. Okay. Oh yeah. One thing which is another source of confusion, which I want to show you. Is, let's run this again. You remember when we logged in with the pure OpenID Connect login client ID, we got all of these claims, right? Like first name and last name and email address and so on. You see that they are gone here now, yeah? And that is basically an optimization mechanism that is suggested by the OpenID Connect protocol, yeah? So now we have to store that session here now stores the access token, it stores the ID token, it stores the refresh token, and actually, if we'll have a look at the cookie size now, it is now 4 kilobytes, and a cookie can get up to 4 kilobytes, and then we have to overflow it in a second cookie and so on. So if now the ID token would contain all that additional user data and the session, right? So the data would be in the ID token itself, and actually to prove that it's not there anymore, yeah? And it would be in the session would probably get unnecessarily big. Okay, so the OpenID Connect spec suggests that if you are asking for an identity token and an access token, then just put the minimal data, just at the bare minimum, which is basically the subject ID of the user, into the identity token, and then use the access token here, which is this guy. Let's have a look again at this. Use this to go to a special endpoint provided by the OpenID Connect provider called the user info endpoint, and then you will get that data as a backchannel call. And this is an optimization mechanism to keep the identity token smaller, because you typically have to store them for sign out time. Again, how would I enable that with ASP.NET Core? It's pretty simple. You would say get claims from user info endpoint. And if I run this again, our first name, last name claims and email should be back now. Let's try this. And lo and behold, here they are. Okay. So here are our claims. You see, they are not exactly the claims we had before. For example, the email verified is gone and the web page is gone, and that is because these claim actions I mentioned earlier, they now filter them out by default. So if you want to bring them back, you have to write a claim action. But the net result of that is that basically our ID token stayed the same size, the session got a little bit bigger. So yeah, it's an optimization mechanism which is turned on by default. You can turn it off at identity server on a per client basis, but I'm just showing that because this is often, ultimately there is some confusion here, because the OpenID Connect handler is doing a lot of things for you, right? It gets it does the authorized request, gets the code, gets the tokens, sends the scopes, does the claims mapping, gets to the user info endpoint. So there is a lot of stuff going on, and sometimes it is confusing why things are working the way they are or not. That's why I showed you all of the ways that you can turn off these little magic features. And also, from a learning point of view, I would encourage you handling all of these various events and just see what you're getting at the various stages of the protocol flows. Yeah, but ultimately it is simple, right? I mean, the scopes determine what you get, and the claims actions are basically the thing that then take the data from the raw tokens and copy them forward into your claims principle. Okay, but yeah. I can tell you from experience that sometimes this needs a little bit of research, and another really useful tool, as I showed you earlier, is this JotMS thing, where you can look at the raw tokens and see actually that's on the wire and that's how the claim was named and why isn't it like this in my session, and so on and so forth. Okay, so that's it. I hope this was useful for you, and yeah, see you next time. Thank you. Bye bye.